Hello everyone. So today I'm here to discuss about my latest project that was facial emotion recognition model by using CNN, and also have implemented REST-NET 50v2 model to use the transfer learning concept. So without further ado, let's discuss the main thing. So basically, in this project, I have built a facial emotion recognition system using deep learning framework. So the system can detect a face, human face, and emotion in two ways. Like by uploading, like I have created a Streamlit front end, basically front end application kind of thing. So there are two types of things. Like by uploading an image, you can easily detect the emotion of the face from the app itself. And another application, basically, it will give the real time detection. So in the video itself, like if it will it will check your face by using the webcam of your laptop, and directly it will through the emotions of your face based on the pre-trained data. So so basically, here we have used the OpenCV, like OpenCV technique, and the model is trained to classify basically seven emotions. Those are angry, disgust, sad, natural, and surprise. So let's see the basically in this case I have used the AFIA 2013 dataset. This is a popular dataset. So these are the details of the dataset. So dataset is consist of 24,400 images, where for training set we have used 22 nearly over 23k images, and for test set we kept nearly over 1.5k images. So these are the classes, those are present inside the classes, in the sense like this emotion related pictures are present into the data sets. So this is the data characteristics. So basically grayscale images to simplify computational requirements. So all the images those are present all over in grayscale. Basically it's not in RGB format, and poses are consistent to focus on facial expression and captures both posed and spontaneous expression for better generalization. So and the first of all, let's start with the main thing, like main code. So here basically I have installed all the required libraries. Like first of all, I have upgraded the PEEP and also installed a TensorFlow, Keras, and OpenCV Python. Those are required for this actually project. And after that, I've imported all the required things, and I've checked the versions and like those are installed correctly or not, because these are the libraries, those are basically need to complete this project. Otherwise it will not run, because we have to use this Keras and those things, image data generator and image processing. So these things are required. So importing these things is a like important thing, I would say. So basically after that, I have injected a data from my local from my drive itself. See, here I have taken like access the content folder under my drive, and I have taken the train and validation set from there. So after that, this one is basically I have just shown the like example of the data. So these are the like one emotion photo I have shown. So this is the sad emotion photo basically. Surprise emotion, natural emotion, happy emotion, fear. This is the disgust emotion, angry emotion. So we have already discussed like these are the emotions those are present. So here basically uh, this part we have created a training data generator by using augmentation. Means like we have uh, like like augmented a data. It means like we have rescaled it, some images we have rotated it, some we have widely shifted, some I have height shifted, shear range, zoom range we have modified, so that model can get the generalization, model can get different types of varying images, so that it can like generalize well with the training data, so that in when real time monitoring will be taken into picture, it can detect easily. The main focus is to that only to, this is done to give some generalization to the model itself during training phase. So basically, we have created two generator. One is for training, one is for validation. So for validation, we didn't do any augmentation here. Only we have rescaled it. So that's all. So basically, this validation generator basically helps the model to learn from one data set and get evaluated on unseen data. So that is our aim. So that is basically common for every model, I would say. So after that, uh, here basically we did the class indices and label mapping. Uh, First of all, I have like created, like I have defined the batch size should be 64 and the target size is 48. Means in each epoch, like model will process 64 images current of that. And color mode I have used grayscale only. The like normal whatever is present in the dataset I have used the same. I have avoided to convert it into RGB. So class mode is categorical because like there are more the like this is a multi-class classification issue, a problem. So that's why I've used categorical. And the same trend generator, validation generator I've created. Here basically we are doing class indices and level mapping. So these indices basically tell the model which numeric value basically corresponds to which emotion. So we are just giving like each emotion we are giving a labeling with number. So that is the thing. So we are just like giving like saying model that 0 is basically mapping to the angry. 0 is basically indicating to angry emotion. That's all, nothing more than this. So I also did the reverse this mapping so that after prediction I can convert the numeric output back into the human readable format, emotion level. So after that, basically, uh, before proceeding with the CNN model architecture, I have just displayed the like augmented whatever augmentation I did with the images. These are the examples. Like we have rotated it, we have changed the scale, we have changed the uh, rotated, we have changed the scale, and also we did some horizontal flip through, shear range, zoom range. These things I did. So this is the basically example of the our augmentation. Now we are coming to the architecture path. So this is the most important part. Here basically we have built the we have used the CNN network, and the first layer is basically the input layer. So here the model basically takes an image of size 48 cross 48 pixel with one channel basically. That will be the grayscale images. So this is the input layer. Here basically model is taking the picture, and after that, this is the convolution block one, where basically the CNN is basically divided into the three convolution block. Like I have used three convolution block here. This is convolution block, three convolution block I have taken, and convolution basically extract the facial features like eyes, like by using eyes, eyebrows, and mouth. Basically, it is to detect the emotion. And also I've used the batch normalization here. See, batch normalization here to stabilize the learning, and also used max pooling to reduce the image size while keeping its important features. So it won't disregard the important features, so it will keep important features and reduce the image size. So, and also I've used the dropout feature here to minimize the to prevent the model from overfitting. Actually, the main motive is to use dropout for this only. So the after that, uh, so these are the same thing I did for the convolution block two also. Like for first one we have used 32 input layer and 60, after that 64, and then we have tried with 128. Then we have tried with 256. After that, we have basically the thing is that key as we move deeper into the network, the number of filters I have increased. Like the initial phase I've used 32 filter. See, the thing is there, 32 filter. After that, to get more generalization, I have increased it to 64 and then 128. After that, 256. You can say, you can see here. So the thing is, like by increasing the filter, I'm allowing the model to learn more complex facial emotions, so that in the real time scenario it can detect easily. So this is the fully connected layer. After feature extraction, I flatten the output and pass it to the dense layer. So this layer basically combines all learned feature. Dropout is basically used for the overfitting case. And after all of this, I have used this is the output layer. Like I have used seven neurons here, so that there are seven emotions are present. So one for each neuron, one for like one in each neuron, so seven emotions are present. So and after that we have used the soft max activation, so that it will convert the output into probabilities. So we know how confident the model is about each emotion. So this is the thing. So this is the model summary part. Whatever we have discussed, I printed just here. So after that, the training part. Uh, so basically, I have used the optimizer here. You can see Adam optimizer here. Like during compilation, I forgot to mention that during compilation, I have used Adam optimizers here, so that it will be fast and adaptive learning. So Adam optimizer basically the thing is that it known for its fastness and the adaptive learning capability. And also for loss, I have used categorical cross entropy, as it's like based for multi-class classification problems. And matrix, I have used accuracy to measure the performance. So uh, so to uh, training uh, so to training more efficient and convenient, I have used the callback thing. And see, here I have used the callback, and I have used the learning rate scheduler. So if validation accuracy, the basically the motive is to if the validation accuracy stops improving, so in that case learning rate is automatically reduced. So that's why I have used the scheduler thing here. So it will help the model to fine tune instead of overshooting the base solution. So and also I've used the model checkpoint. It is basically the purpose is to saved only when validation accuracy improved. Uh, so this ensures always keep the best performing model, not the worst model. So not just the last one. So whenever the validation accuracy is improving, so we are capturing that model. That is the thing. So here this is the basically model training part. Now like I've started like here in this step I've started with the train the model using the train generator, and validating by using the validating the result by using validation generator. So we got accuracy around 67%, and the loss it's 0.92. So the model is decent only. We can like optimize it. We can optimize it by using, we can pass more filter, so that it can detect real-time emotions more conveniently. So here in this case, actually, I didn't done that because like my processor is not allowing me to do that. Like even this simple model, like it took me to complete around 2 days. So that's why the issue that is the reason I have not proceed with that advanced step. So after that, with that result, I have like plotted the accuracy and loss curves. So this blue line basically identifying like denoting the train accuracy, and the orange is basically giving the validation accuracy, you can see. And this is the classification report. Here is the confusion matrix. And also we have tried with the like how the model is performing. To see how the model is performing, I have like tried with some very random images. So it is basically detecting like that. So it is like this phase, the model is giving as angry. This is also angry, and the actual prediction is also angry. So model is correct here, but these things model is fails to predict. Like model is giving some prediction, but actually it is not. So in this case, actually this is happy, and model is also prediction happy. surprise model is also prediction. So let's see, without further ado, let's see the, like, I have implemented ResNet 50v2 model also. Let's see once. So like, let's see the glimpse of the code there. So the same thing I did for the ResNet V50v2 model, also installed all the required libraries and all. I have like displayed all the first emotion pictures, and I have like, here I have loaded the data. So in this case, the color mode I have chosen the RGB, not the grayscale one. So, and I here basically I did the build part of the model. This is the base model, I would say. So after building the base model, I have added the custom layers over here, and here basically I did the compilation part. So at the very end, let's see where basically model training happened. Here I have basically a callback thing I did here, and checkpoint also I did to get the base version of the model, so that when the validation accuracy improves, that time that can able to like uh, take the best version of that model, not the latest one. The thing is that, so also we have used early stop the training when validation accuracy stops improving. So here basically the training happened. So this also took me around 2.5 days actually. So at the very last, we got around accuracy of validation accuracy of 52%. Here we have basically loaded the model to check the accuracy. So test accuracy we got around 52%, that we already discussed. And this is the training and validation curve you can see. And so this is the confusion metric. These are the class-wise accuracy actually. See, so I have tried with random variable validation data as well. So this case model is prediction well, it is matching with the actual prediction. Here also the model is predicting in a good way, but most of the cases it fails to predicting because the accuracy is not that good. We are getting around 52%, but after, like, if we try to refine that, if you have a good processor and good RAM capability, then you can go ahead with the like refining part, so then model can give good prediction. In my case, there is like that is not the case. My RAM is only 8 GB, and my processor is like there is no graphics card, so I'm not able to, I was not able to done that. So in future, if I get that capability, then I will do that. So here basically I'm saving the model. So let's see the glimpse of the thing, like how the model is basically doing. So after this was like I did the model part. So here is the application that I have like built to get the UI part. So let's see first the static page, like where we can upload the image, and based on the image we can detect the emotion. So this is the application code for like normal uploading image and getting the detection part. So here basically all the library that are required to detect, I have imported all the things, and this is the custom CSS code, that the basically the main UI part that I built using the CSS. And we have, after that, we have loaded the model, and these are the emotion label I have like defined. So basically here the all the things are happening. So let's see the UI how it is showing. So this is the emotion detection system. So here we can browse all the files, and accordingly let's upload this picture. So it's taking so basically we have to run that code, like basically this app.py. You can easily open one terminal over there, and just put that Streamlit run app.py, then it will easily run. So see, this is the picture I have uploaded, and if we click over here, analyze emotion, it will like model will predict the emission of this picture. So this baby picture is basically neutral. Model is predicting as the emotion of the baby is neutral. So let's try the real time monitoring system. So let's see the code first. After that, we'll go into that like how it is predicting. So this is the like for real time monitoring, I have built two Python application. So one is for basically the Streamlit UI part, and where the model is basically implemented. Uh, Model is basically we have uploaded, but another py I have built to like detect the webcam part. So this is basically this will uh, check for the webcam is open, like it is available or not, and accordingly it will check the image, the live image. And here basically we have like use the model, the normal app.py thing. So let's like for a few minutes I'm just stopping my camera, as like if we using camera over here, then we can't like use that camera in my application. So let's see. Here this is the application. So let's see, is it is giving or not. Let me refresh it. So here, first of all, we have to select the device. Now see, I have like stopped my camera over there, zoom. So now it is detecting the my HP cam of my laptop, and here I have to push the start, and the model is running now. Let's see. It will take few minutes. See, see. So this is the thing.